All right, hopefully you did well on your quiz. Now we're moving on to section 1.3. So new lesson, new section today. And we're looking at the learning target. I can graph piecewise functions. So if you look down on your first page for the notes, we're looking at some piecewise defined functions. So down here, these are both examples of piecewise defined functions. So it's a function defined by many pieces. So this function takes the form of 2x plus 5 when x is in between -6 and -2. And then it takes the form 2x squared minus 7 when x is in between -2 and 1, and then so on. So let's talk about graphing. So if I wanted to graph this function, what would it look like? So it's going to be 3 pieces. So I'll call this piece 1, piece 2, piece 3. So one function defined in 3 pieces. So I'm going to get a piece of graph paper to do this. So I'm doing this problem here. I'm going to set up my graph, get it ready to the side here. So I'm going to draw my x and y axis. All right, I'm going to start by doing the first piece. So the 2x plus 5 for 6 less than or equal to x less than or equal to -2. So your first step is to determine what is the x values. Where is this going to end on either side? So to do that, you're looking at the x values. So step 1, determine the endpoints. So we're looking at the x values given. So my x values given are -6 and -2. So I'm going to start there. Let's start with -2 or -6. I'm going to take that -6 and I want to find if x is -6, what is y? What is my endpoint there? So I'm going to plug it into the equation. 2 times -6 plus 5. And I'll solve that. So that'd be -12 plus 5, which is -7. So my point is -6, -7. So that was step 2. So plug in x to find y. So I have 2 times -6 plus 5 is -7. My x was -6 here. So -6, -7. So let's plot that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So that point right there. All right, so that was step 3, plot point. So now I need to determine if it is open or closed. If it has an or equal to, that is a closed. So these are both closed here. So let's make a little note. Or equal to closed, no or equal to open. So this one was closed, as you can see right here at my point. All right, so now we're ready to put in the next x value, -2. So I'm going to find my y value for -2. So 2 times -2 plus 5, that's -4 plus 5, which is 1. So I'm going to plot that. And again, it's close because of the or equal to. So -2, 1. It's right here. So these are my ending points of my graph for this piece. So now I just need to draw the graph. For this piece. So I'm going to look back at my original equation, 2x plus 5. That falls under a linear. We know that linear functions take the form y equals mx plus b. That is a linear function, which makes a line. It's just a straight line. So I'll just connect these. Since I know it's a straight line, it's just going to be a straight line from one point to the other. And then we're done with that piece. Now we need to go to the next piece. So our next piece is this 2x squared minus 7. 2x squared minus 7. And we're going from -2 to 1. All right, so let's start the process over again. So I'm going to start with my x values. So this one, we'll start with -2. Plug it in to find y. So 2 times -2 squared minus 7. So I'm going to start, always do your exponents first. So -2 squared, that'd be -2 times -2 is +4. 4 times 2 is 8. And then minus 7, 1. So my point is -2, 1. And that's going to be open. There's no or equal to under there. So -2, 1. Oh, it's the same line. It's already solid, so I'm just going to like lightly mark that so I remember where my point is. But it's going to be solid in the end. So the solid takes over the open in this case. All right, then we'll go to the 1, plug it in. So 1 squared is 1 times 2 is 2. 2 minus 7 is -5. 1, 2, 3, 4, 5. And that's open. Okay, so I've got my 2 endpoints. Now I need to draw the graph. So I'm going to go back to my original equation. This is not a linear. This is not a straight line. I know that because of the squared. The squared makes it a quadratic. And quadratics are parabolas. So my graph is going to take that U shape. Now remember back to last section when we talked about transformations. What does this -7 do to the parabola? -7 on the outside moves it down 7. 1, 2, 3, 4, 5, 6, 7. So that's the bottom of our U right here. So now I can just sketch it. So I'm going to make that U shape, and I know to end down here because -7 shifts it down, and then we can fill in the rest there. All right, so this was a quadratic because of that squared there. All right, last piece, -4 minus x, and we're going from 1 to 3. All right, so we're going to take the first x value, 1, plug it in. -4 minus 1 is -5. So 1, -5. Then we'll take our next value, the 3. Plug it in. You get -7. Okay, so we're going to plot these. 1, -5, and that's a closed. 1, 2, 3, 4, 5. Oh, it ended right here. Remember, the solid always overrides the open. So I'm going to make this solid now. And then 3, -7. And that's closed. Okay, this is a y = mx plus b. That would be your b. Your m would be -1. Negative slopes go down. So we did that right. Just connect your dots, straight line, since it's linear. All right, and then that's done. You've graphed it. This is what the graph of this piecewise function looks like. Now let's just talk about, let's do a little review from last section. And I want to look at this graph, and I want to describe domain, range, increasing, decreasing, and there's no constant, so we don't have to worry about that. Okay, domain, x values, left to right. So the very left of the graph is right here. That x value is at 1, 2, 3, 4, 5, 6, -6. And it's a solid dot, so it gets the bracket. All the way over to here, 3. Range, bottom to top. Here's the bottom of the graph at -7. And here's the top at 1. Now we need to do increasing where the graph is going up. So from here to here. So -6 to -2. And then 0 to 1. And then let's do decreasing. So that's from -2 to 0. And then 1, 2, 3. All right, let's try another one. So let's do, from this paper, let's do this problem right here. All right, so I'm going to draw my graph out. Okay, so my first piece is 3, -4 less than x less than 0. So I'm going to start with my x value, -4, plug it in. There's nothing to plug in there. So the answer just stays 3. So it's -4, 3. Next x value is 0. Plug it in. Again, there's nothing to plug in, so the answer is just 3. Just stays 3. And then both open. There's no or equal to sign there. So -4, 3. Oh, sorry, that should be, I wrote that down wrong. It should be it's closed. And then 0, 3. And it's a constant, just straight across. Okay, next one. So when you just have a number given, that's going to make a horizontal line. Okay. All right, next one is -x from 0 to 2. So I'm going to plug in my 0 first. So -0 is just 0, so 0, 0. Then I'm going to plug in my 2. Plug it in here, so negative, plug in 2 for x, so that's just -2, so 2, -2, both closed, 0, 0, 2, -2. This is that y = mx plus b, it's just a straight line, the negative slope. There it is. Last piece, 3 minus x. 2 to 4. Okay. Start with the 2 here. Plug it in. 3 minus 2 is 1. 2, 1. Open. 3 minus 4 is -1, so 4, -1. 2 through 4, -1. And there it is. And we're done. Now let's give domain. That would be from here to here. So 4, -4, sorry. -4 to 4. Range. And they're both open, so that's why I put the parentheses. Range is bottom, so -2 to 3. Closed, closed. Increasing, none. Decreasing, 0 to 2. And 2 to 4. And then your constant would be -4 to 0. Okay. All right, now let's look at the other notes that say, kind of gives you, I know we already wrote down the success criteria, but here it is typed out a little better for you, a little neater. Okay, so you're going to start, actually pause the video and try these two on your own. Pause the video, try them on your own. Then restart it, we'll check it. Okay, so you're gonna take your X values, plug them in to find your Y values. So I'm gonna start here with this 3x plus 2. I'm gonna plug in -1. So 3 times -1 plus 2 is -3 plus 2 is -1. So that's the point, -1, -1. Now we're gonna plug in 2. So 3 times 2 plus 2, that's 6 plus 2 is 8. So the point 28. Then we'll plot them. -1, -1, and it's closed. And then 2, 8. And that one's open, there's no or equal to there. Check my line. It's y equals mx plus b, so that's the easy one. Just connect the dots. Whoop, I might want to get a ruler for accuracy. Okay, let's do this one. So I'm going to take my first x value, which is 2, plug it in. So -2 plus 8, 2 plus 8 is 6. So 2, 6 is the first point, and that's closed. 2, 6. Plug in 5. So that would be -5 plus 8, which is 3. So 5, 1, 2, 3, and that's open. There's no line under there, so it's open. Again, that's a y equals mx plus b. Connect your dots. Domain would be -1 to 5. Range would be -1 to 8. Okay, let's try the next one. Try this one on your own if you haven't already, and then restart. Okay, so 2x, and this time we only have one x value here, so there's only going to be one point to work with, so plug in 1, so that would be the point 1, 2 times 1 is 2. 0.12, and it's going to be open. 1, 2. 2x, that's going to make a line. That's a linear function. That falls in the y equals mx plus b. So this is a line and it's a positive slope, so it's going to go this way. This is going to be my line right here. And I know that x is less than 1. So here's 1. Where does x equal less than 1? Or where is x less than 1? This way. The numbers get smaller this way. So that means I only want the bottom half of the line. I know the slope is 2 over 1, so I can kind of go, I can go 1, 2 over 1, 1, 2 over 1, 1, 2, and there's my line. Okay, so one more time with that. So I only had one x value. I plugged it in, and I got the 0.12, and I plotted it. It's open. There's no or equal to. And I know it's linear. It falls in the y equals mx plus b. The slope is that mx. So m is 2 over 1. It's positive, so up 2 over 1, up 2 over 1. So the line is going this way, right? So I can reverse that and go down to left, down to left, down to left 1. And then since x is less than 1, it's all these values after 1 there. Oh my goodness, I plotted it at -1. Who caught that? Comment to me if you caught that, if you saw that. Comment just in the class comments, like, I knew it. I caught that, Mrs. Askey. All right. So next one is 4. So 4 if x equals 1. So I'm going to plug in 1. So that's one of those funny ones when there's no x. So it's just 1, 4. The 0.14. 1, 4. And it's equal to, that means that there's only 1.14. And that's it. We're done. All right, x plus 5, we're going to plug in 1. So 1 plus 5 is 6. 1, 6. It's open. Again, this is linear. It's that y equals mx plus b. And slope is 1 over 1, positive. Up 1 over 1, up 1 over 1. So it's going to look like that. And I know I want this side of the line because it's all the x values bigger than 1. So x gets bigger this way. Ta-da! And then domain would be -infinity to +infinity. And then range is kind of weird for this one because we're missing a piece here and we're missing a piece here. So it's going -infinity to 2. And then it's just 4. And then it's, you can say, that's like the symbol for and. Means union. And then 1, 6. 6 and on. 6 and on. Whew. That was a long video. All right, now I want you to do these 4 problems from the homework paper. Just these 4 for today. Don't worry about doing these. Forget this. Do not need to do any of that. But then, so graph it and then answer domain, range, and also increasing, decreasing, and constant for all of them as well. Give those intervals. All right, thanks for hanging in there. That was a long video.